Hello everybody, this is Katie Vandermeer. We're going to go through chapter 7, and again it's a short chapter, few pages. But this chapter is called Input Validation. We kind of started this, actually we did start this already with chapter 5 when we learned about loops, and I said in your assignment, make sure you error code because we want to validate as much input as we can. So from our programs from here on out, you need to check all of your inputs. And input for small basic, we're going to check primarily just our numeric input because of the limitations we have with small basic. But chapter 7 is a good overview of things that you've probably already started thinking about. There's a concept in programming called garbage in, garbage out. If a program reads bad data as input, it's going to produce bad output. So if you ask somebody for their age and they enter in 5,492 and you don't error code or input validate that input, it's going to print that their age is 5,942. Now that's a problem because you didn't fix it. So in our programs for this class, we're going to start with some input validation. So as you read through the chapter, it gives you examples. The pay rate one is a great. You know, you ask them how many hours they worked. If they put in 700 hours and then at $10 an hour, you know, for a week, there's no way they worked 700 hours that week. You don't want to have a paycheck that's $7,000 printed and sent out to that employee, or you're going to probably be fired from your job. So you would definitely input validate that type of thing. So that's what we mean with this chapter and the concept of garbage in, garbage out. Internet. So the question, how do we input validate? We write loops, basically. So it's sort of like a decision, but when we ask, you know, if this number is correct, and if it's not, you want to go back up. So you write a loop to do your input validation. And we really did start doing this in chapter 5, so it shouldn't be anything new. Now you can read through the rest of this chapter as you will with the quiz. I'm having a hard time with my internet and going through here, but I'm going to pull up a couple small basic programs and show you how we've been input validating already. One of the things on page, and I just passed it up, but there's a good example of input validation. But on page 272, you can also input validate with ranges. So you've done that, our last section. And our ranges are typically used with the and not the or. So when you say if score, if you want to check if it's between a range, you use and. If you want to check if it's outside of the range, you use or. So remember that. But here's one where we enter in a test score. If test score is less than 0 or greater than 100, then it's an error. So you notice that loop will take in the value again. When we do input validation, we do this thing called a prime read. So we enter in the test score and then we ask the question. If it's wrong, we take it in again. So here's the read again. So we did that with our last section, and not too much new with this chapter, but I want to reinforce it because when I'm grading some of the material for chapter 5, I've seen that some things have been missed. The chapter's very short, but make sure you read it as you're taking the quiz. And again, there will be one assignment that incorporates chapter 6 and chapter 7 material. String input. So when I will do your assignment, I'll say make sure that you validate your numeric input. That's all your numbers. Anytime you ask for 1, 2, 3 or test score, whatever. Validating string input is done a little bit differently, and it's dependent on the language. So there's some things that we can do with our validation of our yes or the no, where we can check for upper or lowercase, but small basic again is pretty limited in our choices and our options for that. So don't, if you are asking, for something like enter in a name and you want it to, or an address or something like that as a string, we don't have to worry about input validation for this class, but just know that in the future it's something that you'll want to definitely consider and incorporate into your code. It's just that other languages have built-in functions that are a lot easier to handle, like to lower, to upper, and small basic doesn't have those features. So string input validation is done a little differently. The last section on page 277, which you can see, oh, here it is, talks about defensive programming. So this is input validation is part of the practice of defensive programming. Thorough input validation anticipates both obvious and unobvious errors. So your job is to think of all the stupid things that people who are using your program will enter in. And you want to fix that. So for example, Word does defensive programming or does error code when you do something like, let me save this file and save it, and I'm not sure if it does it or not, but say you have a file name that is like something wacky and not acceptable by file name standards, like that perhaps. That should cause some kind of error, I would think. And when you try to save that, okay, we have that. Ooh, it actually is going to work. But that should have been like, this is not a standard file name, and then processed an error where you would ask the user to enter in a proper file name. That's an example, although a poor one because it actually did work. But if I were the programmer of Word, and I would prevent that from being a file name. 9 slides. Read through these slides as you go through the chapter. Biggest things. Input validation is done with loops, not just an if, because an if just goes down. The loop goes back up. We use a prime read. So we ask the question, we check it. If it's wrong, we ask again. That's as simple as it gets. We'll do as much string validation as we can, but in the meantime, just focus on your input or your numeric input validation. And then defensive programming. Here's it. Oh, this is a better example. I should have read this. State abbreviations, 2-character strings. So, or zip code, 5 or 9 digit. When you enter in a zip code online in like a web form, and if you only put 4 digits, it'll error and it'll say, you must enter 5. So that's example. That's a better example than my Word example. Okay, let's look at some defensive programming for this one we are working on. I'm adding input validation for chapter 7. So running through this program, remember, what is my input? So I have asked here's my input. Enter 1 or 2. What if I enter in 7? Well, it does 2, but I didn't say to do 2. I said to do something else. It just does the default. So I want to input validate that. So there's my first one right here. How do we do that? Very simple. We have our prime read. So this is now our prime read. And I'm going to take this and copy it. Control C. And then I'm going to do my input validation loop, and I'll say while option is, so 1 and 2 are only the valid options. If I had something larger, it would go, but I'll say while option is less than 1 or option is greater than 2. So if it's less than 1, 0, -1, or greater than 2, meaning 3, 4, 5, then I'm going to print a window text window dot write line. Must be a 1 or a 2. Try again. Do over, da da da. And I just pasted my code. And what do we do at the end of a while? We end it, and that's it. Now when I run my program, I have some, I should just slow down. I have some input validation for 1 or 2. Pretty easy. Now make sure you're using the ands and the ors right. You know, if it's outside of the range like this, then you use or. If you want to do it kind of differently, and the and is checking between a range. So enter a 1 or 2. I put in 7 this time, and it won't let me go on until I enter in a 1 or a 2. And then it goes. String validation, let's see what our limitations are with small basic. But enter yes or no. So you could really enter anything other than yes, and it will quit. But I think that if we enter in a, let's see if we enter in a capital yes, I've checked for lowercase yes, and it ends still. So you can do some sort of input validation or some checking with our strings, but I'm not going to focus on that. Here's my while loop up here. While again equals yes. I could say or again is equal to yes. Or again is equal to yes, and just use different caps. Some languages have a method called to upper, to lower, and I don't think this one does. To upper again equals to upper. No, it doesn't have anything, but some languages have to upper, to lower, and it'll convert the characters for you. But this is something you could do. But then again, you know, don't worry about it, because they could do a capital Y, a lowercase e, and a capital S, and it'll be wrong because it's not this. So the point there is to remember that strings are read in character by character, and they are case sensitive. We don't have any other input validation in this program where we're taking in numbers, but we could have a range. So let's say, because you'll do this, let's say that we want to use this math.power, and we want to ask for, so when we use math.power, remember we have 2 arguments that are passed to it. Let me look at this. There we go. That's what I wanted. We have the base number and the exponent. Those are 2 arguments. So instead of using 10 and 2, let's use 2 variables. So let's ask text window dot write, enter your base number and base number equals text window dot read number, and then enter in the exponent. What do we want to raise it to? And so now we have two variables, base number and exponent. So I'm going to replace 10 and 2 with those. Base number, comma, exponent. And let's run it, see if it works, and then we'll do our input validation. So I had 10 and 2 before. Let's say I want to raise 5, and I want to raise 5 to the 5 to the power of 4. That answer is 625. So 5 times 5 is 25, times 5 is 125, times 5 is 625. Yeah. So that works. But we didn't input validate it. So let's do that. And let's say we want to do a range. So enter your base number between 1 and 10. And what number do you want to raise it to? And we'll just say it must be, let's see. So if we said 10 and we raised it to the power of 0 is 1. Is that right? Let's say that we have to 10 raised to the power of 1 is 10. So let's say, I'm not great with math, but let's say that we're only going to validate that so we don't accept negative numbers. So let's validate our exponent first because I just mentioned that. Let's only enter positive numbers. So we'll want to say while, actually, remember, prime read, always start. So here's our prime read, which we already have. I'm going to copy that because I'm lazy and I don't want to make errors. And then I'm going to add an input validation loop. And I'll say while exponent is less than or equal to 0. I don't think we can raise a number to 0. So we'll just not accept 0. And if you're a math whiz and you're yelling at me, I'm sorry. And then end the while. Whoops. End while. End while. And we should probably print an error. Text window. That right line. Error. Enter. You must enter a number greater than 0. Try again. Okay? Validated. And prime read, if it's less than or equal to 0, take it in again, and then it'll go down to do your calculation. And here's another number. We need to input validate our base number. So input validate. And this is our prime read. So we ask the question. I'm going to copy. By the way, a lot of times when I do my input validation, I'll code it, go through and code it, make sure it works, and then go back and do my input validation. That's just something that works for me. You can do it at the same time if you want, but that's up to you. So let's do our while, and I'm going to do a range because I said 1 through 10. So while base number is less than 1 or base number is greater than 10, and just checking. Oh, I put parentheses in there, but we don't need them. Less than 1 and greater than 10. Okay. Error. Need a number 1 through 10. Ding, da, 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 forgot my quote, and paste my read again. and end my while. There we go. So this program, no matter what it's doing, which is a lot of things, it is validating every possible thing I can input. Enter base number between 1 and 11. Error, we need a number between 1 and 10. Okay? I kind of don't like how that looks, so I'm going to do a right line here. Whoops. Okay, 11, error, entering again, 0, nope, 990, nope. Okay, let's do 7. What do you want to raise it to? 0. Nope, I want to raise 7 to the power 2, answer's 49. I am not going to get past that part of code until I enter in a 1 through 10 or any number greater than 0 when it comes to the exponent. It is protected as best as I can. Same with this part, 1 or a 2. That's all your options are. Nothing else other than a 1 or a 2. And here I've done the best I could with my yes or my no, according to Small Basic. So when I see in the future with your programs, input validate all your numerics, this is what I'm talking about. Make sure you do it. It's going to be fun. It's the best way that we can defensively code our programs at this point. Seems like there was one other thing I wanted to tell you. So we have a range. I think that's it. Anyway, enjoy chapter 6 and 7. Enjoy reading them and enjoy the program.